Today we're going to be talking about distributions and different types of distributions. So let's think about what a distribution is. So if we look at a definition of distribution, the distribution of a variable tells us what values it takes on. And how often. So an example would be the different brands of cell phones that students have. So we have Samsung, we have Apple, what do we Nokia, LG, HTC, and so on. So let's just say on the y-axis we have the number of students. So in this graph we'll say, for example, that 20 students have this phone, 50 students have this phone, 5 students have this phone, 3 students have this phone, 8 have this one, and maybe 10 have this. So we're going to draw the histogram of this. Okay, the histogram. Sorry, this is going to be a bar graph. It's called a bar graph. Okay, bar graph represents each category. So these are the different categories. So Samsung has 20, so it would go up to here. Apple 50, way up here. Nokia 5, LG 3, HTC 8, and Motorola 10. So this is an example of a bar graph. It displays categorical variables on the x-axis, and on the y-value, or on the y-axis, it tells you the values that they take. So let's look at a histogram. A histogram, in contrast, is a distribution of one quantitative variable. Okay, and a quantitative variable takes numerical values for which arithmetic operations such as adding and averaging make sense. Okay, so quantitative means it's measurable, like the height of the water in inches, or the time in seconds, etc. Okay, so we're trying to sketch a distribution of a quantitative variable. So an example would be percent who smoke cigarettes in the southeast. Okay, so let's just say we have these states. I'm gonna abbreviate for Mississippi. Tennessee will include South Carolina, and North Carolina. So let's just say we found the total population of everyone living in the southeast, and we're trying to find the percent of people who smoke in each of these states. So this would be the percentage that smoke within the Alabama population, within Florida, etc. So in Alabama, let's just say it's 30. Florida is 20. Georgia, 25. Mississippi, 5. Tennessee, 18. South Carolina, 50. North Carolina, 22. Okay? So the first step is to choose classes. So we're going to say percent that fall between let's just say between 0 and 10%. And then we have 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60. Okay, so we chose classes. In order to figure out which class these falls into, we're going to have to draw a table. Okay, so between 0 and 10, how many states fall in that category? let's just see, we have Mississippi, and that's it. So there's just one there. Now between 10 and 20, and we'll include 20, so we have 1 and 1 there. Between 20 and 30, we're not including 20, so we have 1, 2, 3. 30 and 40, we're including 30. We have 1, and then none between, 1 between, none between 40 and 50, and 1 right there. Okay, so let's clarify whether we're including it or not. Here, we included the 20. Sorry, we didn't include it, so it's just 18. Here, it was the 5 right there. Here we included the 20, and I'm going to use a bracket for that. So that was 20. What else? 22, 25. Those are the 3. And we didn't include the 30. So we included the 30. That gives us this 1 right there. 40, not including 50. There are none in that category. So we had a 0, and then we had 1 here. Okay, that covers everything. Now, once we've computed our classes, we can draw the histogram. So I'm just gonna draw it really small right here. Okay, so the scale here is going to be percent, and we can have 0 right here, 10, 20, 30, and I'm sorry this isn't legible, let me rewrite it. And then this is the count, the number of states. The number of states that fall into these categories. So we can have 0 right here. This is going to be 1, 2, and 3. Okay, from 0 to 10 we only have 1. So that bar goes like that. From 10 to 20 we have 1, so it stays there. 20 to 30 we have 3. It goes up. 30 to 40 we have 1. 40 to 50 we have none, and then 50 to 60 we have 1. Okay, so the distribution is approximately symmetric. So the ways we can describe a distribution are the following. We can describe it by its shape, its center, and its spread. Okay, the shape can be symmetric, or skewed. Okay, so if they're symmetric, you'll have a distribution that looks something like this. Symmetric. If it's skewed, okay, you'll have something that looks like this. Okay, this is skewed. Skewed right. So what does it mean by skewed? A distribution is skewed right if the right side of the histogram extends much farther out. So the right side extends much farther out. So skewed left, as you would imagine, looks something like this. Skewed left. So how can we describe the center? The center we can usually describe by either the mean or the median. The spread we can usually describe by the standard deviation, which we'll talk about in another lecture. The last thing we want to define is an outlier. An outlier is a value that falls outside the pattern. Okay, an outlier is a value that falls outside the pattern. So why don't we quickly review outliers. Let's just say we had this set of data, which is test scores. So one person made a 2, we had 30, 38, 40, 45, 48, and 50. Okay, and we were trying to graph this distribution. Okay, so again, if we were going to draw a histogram, we do categories. So 0 to 10, not including 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. So how many fall in these categories? 0 to 10 we have just 1. 10 to 20 we have 0. 20 to 30, not including 30, we have 0. 30 to 40 we have 2. And then 40 to 50 we have 1, 2, 3, 4. Okay, so if we were to graph this in a histogram, we'd have 0, 10, 20, 30, 40, and 50. And 0 would be there, 1, 2, 3, and 4. Okay, how many fall within 0 to 10? We just have 1. 10 to 20 we have 0, 20 to 30 we have 0, and then 30 to 40 we have 2. And 40 to 50 we have 4. So this right here, the one that lies outside, is called an outlier. Okay? And the shape of this distribution, let's just say we had more points, and it looks something like that. You could say, and let's just say we had some values here. This would be skewed left. Skewed left if it had these values in red. Now if it was just the distribution in black, which I have up here, this would be an outlier. Alright, that concludes our first lecture on distributions. Thank you for joining.